Namaste, welcome to Pythagoras Academy. In today's video, we'll talk about Newton's third law, which is also known as law of forces. It is the fundamental law of nature, which says that forces exist in pairs. For every action, there is an equal and opposite reaction. This is the statement that we have been studying from our schooling. But somehow, that statement gives an impression that action and reaction are on the same body. And we have this statement given as action is equal to minus reaction, which is not very clear description of Newton's third law, which says that action plus reaction is zero. Again, as I said, it might give an impression that action and reaction acting on the system is zero. If action and reaction acts on a single system, on a single body, then the body wouldn't move. And we have studied that the rocket works on the principle of Newton's third law. So let me clear the concept of Newton's third law. Point number one, action and reaction are forces. And point number two, action and reaction will not be on the same body. They are on two different bodies. For example, say you have placed a block on the ground. The block is pushing the ground, which is action, and the ground is pushing the block back, which is a reaction. So to talk about Newton's third law, there must be a couple of bodies, not a single body. So if there are two bodies A and B, if a body A exerts a force F on B, then B would exert a force minus F bar on A. So minus F bar is the force of same magnitude but in the opposite direction. This is action and this one is reaction. So action and reaction are on two different bodies. They are not on the same body. This is the perfect explanation of Newton's third law. So the statement of Newton's third law would be, if a body A exerts a force F bar on B, then B would exert a force minus F bar on A. If there is a force, there are always two ends of the force. Force is always applied by somebody on somebody. So if A is applying a force F on B, then as a counter, B would apply a force of same magnitude in the opposite direction on A, which is known as reaction. So for every action, there is an equal and opposite reaction, but they are on two different bodies, two different entities, not on the same body. So this would be the statement of Newton's third law. If you take the rocket propulsion, so when the rocket kicks off, the rocket is exerting a great force on the ground. When the rocket is exerting a great force on the ground, which is action, as a reaction, ground exerts the equal amount of force in the opposite direction on the rocket, which is known as reaction. Due to this reaction force on the rocket kicks off. It takes off. So this is how we apply Newton's third law. Now, if I ask you a question that this is the earth, and there's a table, and there's a book. So the mass of the book is, for example, say m. And if I ask you, what is the reaction force of the force applied by earth on the book? So basically the force applied by earth on any mass is known as weight. So mg down. Weight is always acting downwards. The force applied by earth on the book of mass m is mg downwards. If this is action, what would be reaction? Most of the students will tend to think that the reaction force is this normal reaction. But it is not so. As I have explained now, if a body exerts a force F bar on B, B would exert a force minus F bar on A. So what are A and B in this example? A is the earth and B is the book. A is exerting a force F, which is mg downwards, which is action on the book. So as a reaction, book would exert the force mg on the earth. This is reaction. this mg and mg are action reaction pairs. Every force will have its counterpart. Forces do exist in pairs. This is the aim, I mean this is what Newton wanted to convey using his third law. Forces do exist in pairs in nature. If there is a force applied by one body on the other, there is always a counter to it. So the correct explanation for this would be the reaction for this particular action. And what about this? This is normal reaction for the action caused by the book applying some force on the table. Book is in contact with the table. There is normal contact force applied by the book on the table. This is normal action, and this would be normal reaction. So these two will be action reaction pairs. So this is the correct understanding of Newton's third law, and with this understanding you would never go wrong when you are solving a problem of classical mechanics. Thank you.